Assalamu alaikum. In today's period, we are going to start with the first chapter. It's about atoms. This chapter is already discussed in grade 8 and in grade 9, but because it's one of the building blocks of chemistry, we're going to discuss it deeply this year. The objectives to be covered for this period are to define atom, describe in detail the structure of the atom, recognize the charge and the mass of each of the subatomic particles in coulombs and kilogram respectively, represent an atom by the symbol of its nucleus, and finally determine the mass number and the atomic number of an atom. All what you need is to grab your pen and your chemistry booklet. Atoms are tiny particles that are so small that cannot be seen with the naked eye. The only possible way is to use a powerful microscope called the scanning tunneling microscope. Everything that exists in our universe is made up of atoms, including you, I, and the device that you are watching this on. In fact, there are about 7 billion atoms in your body alone, which is 7 times 10 to the power 27 atoms. But what is an atom? So, an atom is the smallest particle of matter that conserves its chemical identity. The word atom comes from the Greek word atomos, meaning indivisible or uncuttable. This idea was first suggested by the Greek philosopher Democritus. But now we all know that an atom is made up of two regions, the nucleus and the electron cloud. Also, it's made up of 3 subatomic particles. These are the protons, the electrons, and the neutrons. Both the protons and neutrons are called the nucleons because they make up the nucleus of the atom. Now, let's discuss in details the characteristics of the subatomic particles. As mentioned previously, the particles are protons, neutrons, and electrons. Both the protons and neutrons are located in the nucleus of the atom, while electrons are located in the electron cloud. In grade 9, we've learned that the mass of each of the subatomic particles is measured in U or AMU, the abbreviation of atomic mass unit, a unit used to express the mass of tiny particles. The mass of a proton is 1 U, which is equal to that of a neutron, while the mass of an electron is 1 over 1840 the mass of a proton. The value is approximately equal to 0. The mass of a proton is equivalent to 1.67 times 10 to the power minus 27 kilograms. The same as that for a neutron, while the mass of an electron is 9.11 times 10 to the power minus 31 kilograms. These masses are very small because we are dealing with tiny particles that makes no sense if we measure their masses in a gram or in kilogram. The relative charge of a proton is 1 plus, which is equal to the relative charge of an electron but with opposite sign. Neutrons are called so since they have no charge. The charge of each of the subatomic particles is expressed in coulombs. The charge of a proton is a plus 1.6 times 10 to the power minus 19 coulombs or plus E. The charge of a neutron is 0. An electron has the same charge as that of a proton, but with opposite sign, so it's simply minus E. Each subatomic particle has its own symbol. Protons are symbolized by P+, neutrons are symbolized by N0, electrons are symbolized by E-. To convert from AMU to kilogram, remember that 1 AMU is equivalent to 1.67 times 10 to the power minus 27 kilograms. Also remember that the absolute value of the charge of a proton or an electron represent what is called by elementary charge E, where E is equal to 1.6 times 10 to the power minus 19 coulombs. As you went over the characteristics of the fundamental particles of the atom, guess which subatomic particle identifies an atom? Protons, electrons, or neutrons? Pause the video and think of the question. Absolutely. It's the atomic number, the number of protons in the nucleus of the atom. The atomic number determines the identity of the atom. Just as every one of us has his own identity card, an element has its unique atomic number. In nature, there are over 118 elements, and each has a specific atomic number. It's very important to keep in mind that this number never changes. Carbon, for example, has an atomic number equal to 6, and this what defines carbon as carbon. Another value characterizes an atom. This is the mass number, denoted by A. The mass number, also called the number of nucleons, represents the number of particles having mass. These are the protons and the neutrons. So A equals Z plus N, where A is the mass number, Z is the atomic number, which is equal to the number of protons, and N is the number of neutrons. Two other relations could be derived from the original one. N equal A minus Z, used to calculate the number of neutrons, and Z equal A minus N, used to calculate the atomic number Z. The composition of the nucleus of an atom is shown by its atomic symbol. We use the chemical symbol of the element with two additional values written to its left. A, which is the mass number written on the upper left side, and Z, which is the atomic number written on the lower left side. Example: lithium, Li37, is the atomic representation of lithium atom. It's also known as the nuclear representation. Each nucleus also is characterized by the plus ZA, and it's called a nuclide. It could be also written as XA, and this is called the shorthand notation. Example: Li37 is the nuclide structure of lithium atom, and Li of mass number 7 is its shorthand notation. Now pause the video, refer to worksheet 1 of your worksheet booklet, and solve application 1. Now it's time to correct the application. In this application, you are given the atomic symbol of different atoms, and you are asked to fill in the table, which doesn't require justification. I'll be discussing just the first two columns of the table. Let's start with the first column. You just have the name of the atom, which is helium. The number of positively charged particles. These are the number of protons. So the number of proton is equal to the atomic number, the number that is written on the lower left side of helium atom. This is equal to 2. The number of negatively charged particles. These are the electrons. So the number of electron is equal to the number of proton, equal to 2 in a neutral helium atom. Number of uncharged particles. These are the neutrons. You know previously that A equals Z plus N. So N equal A minus Z. Here A is equal to 4 because it's the number that is written on the upper left side of helium. So 4 minus 2 equal to 2. Now moving to the second column, you are given the number of negatively charged particles. These are the electrons. So the number of electron is equal to 16, which is equal to the number of proton in a neutral atom. Number of proton is equal to the atomic number Z, so Z is equal to 16. As a result, the atom is sulfur, which is symbolized by S, since an atom is identified by its atomic number Z, and hence the number of positively charged particles is 16. Number of uncharged particles, these are the neutrons. N equal A minus Z, A equal to 32 minus 16, which is equal to 16. Let's move to a second application. Given the nuclide structure of a chromium atom, Cr2452, do you remember the significance of the two numbers, the 24 and 52? Right. 24 is the atomic number, which is equal to the number of protons. 52 is the mass number, which is the number of nucleons. This is the number of protons plus number of neutrons. The first question, determine the composition of a chromium atom. Keep in your mind, if you are asked about the nuclear composition, you have to calculate the number of protons and number of neutrons only. If you are asked about the atomic composition, you have to calculate the number of protons, electrons, and neutrons. Here in the question, you are asked about the composition of a chromium atom. So let's start with the number of protons. The number of proton is equal to the atomic number Z, equal to 24. The number of electron is equal to the number of proton, equal to 24 in a neutral chromium atom. The number of a neutron is calculated using the rule N equal A minus Z, so 52 minus 24 equal to 28. Let's move to the second question. Give another atomic representation of a chromium. You can write one of these two representations. Finally, it's time to summarize. Let's recall what we have discussed so far. An atom is made up of two regions, the nucleus and the electron cloud. Inside the nucleus we have the nucleons. The number of nucleons is equal to the mass number A. The mass number represents the number of protons and the neutrons. The number of proton is equal to the atomic number Z. Also, it's equal to the number of electrons in a neutral atom. The mass of a proton is equal to 1.67 times 10 to power minus 27 kilogram. A neutron has zero charge and a mass equal to that of a proton. Inside the electron cloud, we have the electrons. An electron has a charge of minus e and a mass of 9.11 times 10 to power minus 31 kilograms. An atom could be represented in three different ways. These representations are called the atomic or nuclear representations. For the next period, please watch the video again, then memorize in worksheet 1 of your worksheet booklet the following concepts: the definition of an atom, atomic representation, characteristics of the subatomic particles, atomic number and mass number, and finally, solve application number 4.